Now that we know the basic understanding of linked list and how the singly linked list will actually look like, let's just get started with the implementation of singly linked list by setting up the structure for implementing the node that we have in the singly linked list implementation. Basically, singly linked list is nothing but collection of nodes, right, in which each and every node is connected to the next node. That basically means that in whatever the singly linked list that you see on the screen, right, this is one node, code is another node, true is another node. Likewise, each and every value is a node in which it has the value and it also has the connection to the next node that it is connected to. When it comes to the tail node, right, which is nothing but the last node that we have in the singly linked list, it is not connected to any other node. After observing this singly linked list, any node that you define in the singly linked list basically should have two functionalities. One is to store the value that user wants to store as part of that node, and the second functionality is to store the reference for the next node that it is connected to. Okay, using this next node we will be able to go on to the next node. As a result, we will be able to reach till very last value we have in the case of singly linked list implementation. That's the reason why keeping track of this next reference is absolutely important in the case of singly linked list or any type of linked list implementation. So we have to make sure that whatever the node structure that we are defining has the capabilities to store the value and also store the reference for the next node. Okay, one thing that you have to remember here is, since singly linked list is a heterogeneous data structure, we should support all type of data storage. That basically means that I may want to use some numeric value, I may want to use some boolean value or some other floating value as well. Okay, so ultimately whatever the type of value that I want to store in a specific node, basically each and every node should support that heterogeneous data storage as well. Okay, so that is something that is very important once again as part of value functionality on a singly linked list node. So out of the box, no programming language will basically provide us this kind of structure, right? So we have to write our own class to represent the node that we have in the case of singly linked list. So for that, what we will do is we will basically define a class called node. Okay, in this class called node, basically we need two things. One is value and the other is reference to the next node. That's the reason why we will define two variables called value and another variable called next. Here value variable is basically used for storing the value of the particular node, and next is basically used for storing the reference of the next node that particular node is connected to. Okay, so this is the structure that we will be defining. But in my singly linked list implementation, right, I keep on adding more and more values onto my singly linked list. That basically means that I will keep on adding more and more nodes onto my singly linked list. At that time, basically whenever I create the object of this node class, I am going to assume that I will not worry about this next condition, but based on the functionality that I will implement. Like I mentioned, we will be implementing push, pop, shift, unshift, various other sorts of implementations, right? So I will basically worry about adjusting this next pointer, basically reference of the next node in those specific functionalities. But when I create the object of this node class, I will only worry about taking the value from the user and storing that value as part of this node. For that, basically what I will do is I will create a constructor. So this whatever the constructor that I'm going to define, it will basically take the value from the user, and whatever the value that user passes, it immediately assigns to this variable. So immediately we will define a variable, value variable that we have, right? We will add whatever the value that we get to this specific variable. As I mentioned, at this point of time I will not worry about adding the next node, right? That's the reason why whatever the next that I have, I will simply assign null to this. Okay, once again I'm mentioning, when I go ahead and implement the respective functionality, I will make sure that I'm assigning the appropriate next node from the node that I'm adding at that functionality implementation. So don't worry about this at this point of time. Basically when I implement those functionality, you will basically understand how these next is getting assigned with the appropriate next node. Okay, so only thing that we have to worry here is we will define a class. In this class basically we have two variables, one is value and the other is next, and to add the value into the node object we basically added one constructor which takes the value and simply assigns that value to whatever the value variable that we have. Okay, so that is the structure of singly linked list node class. Now that we know this, let's go ahead and let's try to implement it. So far we have learned about arrays and searching and sorting algorithms, right? Now we are moving on to singly linked list. So I want to put all these files into a single separate folder. So I'm creating a new package called singly linked lists. Okay, in this folder I'm going to create a new file called node.py. okay, in this file let me just create a class called node. Okay, let's try to write the constructor for this. So the constructor is def __ init. The first argument will always be the reference of current object. When I initialize the value of the current node, we basically understood that there will be two values as part of the current node, right? One is the data or the value that we are storing as part of the current node. Along with that, we also want to store the reference to the next node if at all if there are any nodes in the further of singly linked list. So for that, so I'm going to take the first argument as value. Now whatever the value that user has passed, I will try to store it in the current node. So how will we do that? Self dot value equal to value. Okay, now whatever the value that user has passed, we assigned it to a variable called value in the current object. Now along with this value we also want the reference to the next node in the singly linked list, right? So for that I'm going to create a variable called next and I will assign it to none here. Okay, so what exactly we did, as per our previous discussion, we understood that there will be two values inside the node of a singly linked list. One is the value that we want to store. Along with that, we want the reference to the next node in the singly linked list, right? So when I create the object of node, I'm taking the value and I'm assigning it to the current node's value variable. Along with that, at this point of time, I don't know if there are any further nodes in the singly linked list or not, right? That's why I'm just assigning the none to the next reference of the current node object. At the time of implementing separate operations on a singly linked list, I will make sure that I'm adjusting this next variable to the exact next node that we have in the singly linked list so that we can, we would have adjusted the references properly. Okay, this is how we actually represent the singly linked list node using Python.